So for these 6 transition functions, we try to write the variables, that means productions. So first we check whether this is the left side variable, whether all these variables are available here. If it is available, you put tick mark. So you check the first format, there are 4 variables are available. That combination is Q, Z0, Q, Q, Z0, P. So you just go to here, Q, Z0, Q, Q, Z0, P. So these 2 variables contains productions. And if you take the second transition function, 2 productions are possible. One is QXP, another one is QXQ. So QXP, QXQ. This is also contain productions in it. Then here for the third transition function PXP, so just put a tick mark for that one. And for the fourth transition function, the values are QXQ and QXP. So QXQ, QXP already put a tick mark. Then go to the fifth transition function, it is QZ0Q. So you just put the tick mark, QZ0Q, that is also marked. And the next combinations are PZ0Q, PZ0P. So PZ0Q, PZ0P. So these 7 variables are available, but PXP does not contain a production from these 6 different transition functions. So this will be marked as useless variable, because it does not have a production in it. So wherever PXQ is available, you just put a wrong mark for those productions. So for each transition function, we try to write the productions with the 4 formats, type 1, type 2, type 3 and type 4 formats. If any symbol or a variable like PXQ, first you should identify those notations. So PXQ. So here there is no PXQ for the first one. For the second one, here PXQ is available. So this does not contain a non-term wave production. So you put wrong mark for PXQ. Here there is no PXQ. Here PXQ is available. You put wrong mark. So wrong mark means this production is not necessary. So I put wrong mark and strike out those values. So here PXQ, there is no PXQ for the remaining one. So I just underline those notations. So this is step 3. And then you just check another useless symbols. There are 3 different format of useless symbols. First one is a variable that does not contain production. Second one is a variable that will not produce string. That means that not produce input value. So the same symbol will be repeated at right side also. So you just check those notations. For example, here QZ0Q, there is no QZ0Q at right side. Here QZ0Q is available. Here also QZ0Q is available. So this left side variable is repeated at right side. So we want to check whether any another QZQ production is available. So this is QXP production. This is QXQ production. I want to search QZ0Q production. So QZ0Q production, so it contains epsilon. So there is no problem for continuing this one. Then I want to check the remaining productions. QZ0P, it is not available here. QZ0P, it is available here. QZ0P. Then I want to check QZ0P is available here. So I want to check another notations for this production. Q Z naught P. Q Z naught P is not available. So Q Z naught P is not available. So I consider this is the second type. That means this variable contains a production, but this production does not produce input string because the same symbol is repeated here. If it is repeated, instead of this notation, we want to replace these symbols because we already know the grammar derivations concept. In a derivation concept, instead of a non-terminal symbol, we should replace it with its right side of production. So this is the right side of production. This is the left side non-terminal. Instead of this, we want to write this one. So here also the same non-terminal is available. So at no way it can able to produce input string. So the Q Z naught P will be treated as useless symbol with the help of type 2 notation. So I put wrong mark here. Q Z naught P. So wherever Q Z naught P is there, you just strike it out. So you cannot use Q Z naught P. So I just strike it out. Q Z naught P. So here Q Z naught P, this one Q Z naught P, it's not available. Okay, then you check the remaining notations. So here it is not repeated. So in this thing, so just check the second production, QXQ. Here also QXQ. Then once again QXQ is available. But there is no QXQ another production. So this will be considered as second type QXQ. So wherever QXQ is available right side, you put wrong mark QXQ. Then previous slide QXQ. That's all. So I put wrong mark for all these things. Then QXP. Here QXP is available. I want to check QXP value. So QXP contains some values in it, 0 PXP. So some notations are available. Okay, this is step 3. Then step 4 is I want to write the production. So it should take the starting state. So first I am writing the starting state. S implies this will be written from the first step. So in first step, these are all possible productions. So I am only taking the first type notation. So S implies Q Z naught P. So I am taking the first one. So S implies Q Z naught P. This is the variable. So this variable should contain production in it. So I want to search from those 6 different transition functions. So Q Z naught P. So where is Q Z naught P is available? Here Q Z naught P is available, but I strike it out it. Then any other Q Z naught P? No. So I cannot able to write it because I already strike out the productions. So I want to I want to check QXQ. QXQ is available. This is also repeated at right side, but there is no QXQ. So it comes under second type. So QXQ is useless symbol with the second notation. So I use double line here. So wherever QXQ is available, it should also be considered as useless productions. Here QXQ is available. So I want to strike out it. Then any other thing, this is QXQ. So I mark double line as useless symbol. Here also QXQ is available. So this will also be considered as no mark. And here 2 notations are available. Okay. Then the next step is I want to write production with the initial symbol. So S implies this will be retrieved from previous session. So these are all possible production. I am only taking the first one, Q Z naught P. So I am writing Q Z naught P here. So wherever square bracket is available, this will be considered as variable. So this variable should always contain production unit. So I want to write that production. So Q is at not P. I just check it out. Q is at not P. Here Q is at not P is available. So I want to write that value. Q is at not P implies 1 QXP. P is at not P. So I want to write that production here. 1 QXP. It is one variable and another variable is P is at not P, isn't it? So I write this function, so I put tick mark here. So here two new variables. The first new variable is QXP. Another new variable is P is at not P. So I want to write these productions from the previous one. So first I want to check QXP production. So here there is no QXP. This side QXP is available and only one QXP. So QXP implies 0 PXP. So 0 PXP. It is a new variable. So I want to write its production here. Then P is at not P. So P is at not P? No. Here it is no. It is no. Here it is available. P is at not P. It is 0 Q is at not P. 0 Q is at not P. That's all. This is already available. Then I want to go to PXP production. So PXP. PXP, it contains only one production. That value is 1. Okay. Then for every new variable, so I just change the pen color. So this new variable is considered as A. This will be considered as B. This is C. And this is D. So I just only change the production for my viewpoint. So S implies A. A implies 1BC. B implies 0D. And then this P is at not P is C. C implies 0. This is nothing but your A, capital A. And the PXP value is D. D implies 1. So totally 4 new variables are available. But those 4 variables should produce input string. So here D produce input derivation. So instead of C, if you are using 0A means A once again contain 1BC. So this variable C does not produce input string. Here if you take capital B, it contains 0D. Instead of D, we can able to substitute 1 means B produce an input string. Here B produce input string but C can't. So you cannot able to produce input string for A. So if I am taking Q is at not P as a production, this will not derive the input string. So I go to the next format. So that means the second format is Q is at not Q. So I just write its notation. So the notation is Q is at not Q. Once again I just search that production here. Q is at not Q. It is 1 QXP. P is at not Q. So 1 QXP. P is at not Q. So these are all new variables. So I want to write QXP value and also P is at not Q value here. Okay. Once again I want to check Q is at not Q production. So here Q is at not Q production is also available. It is epsilon. So another value is available for the same production. So I write with slash. So we can able to combine more than one production for a single variable. So I write only slash here. Then QXP. So QXP is 0 PXP. So it is already available 0 PXP. Then P is at not Q is 0 Q is at not P. Q is at not Q. So P Z naught Q is Q Z naught Q. It is already available. Then PXP is 1. So now I consider this is capital A, this is B, this is C, this is D. So we can able to write it as starting symbol S implies capital A implies 1BC by epsilon, capital B implies 0D, C implies 0A, D implies 1. So here this variable produce input string. If I am substituting D value to B, B produce it. C means 0A, A means either you can substitute 1BC or epsilon. If I am substituting epsilon, C produce input string. If B and C produce input string, A can also produce the input string. So the correct CFG production is this one. So therefore, CFG G is equal to VTPS. So here the variables are A, B, C, D. Those are all the variables mentioned here, and terminal symbols are 0, 1, epsilon. Productions are totally 5 productions are available, and the starting symbol of the production is capital A. So the capital A value is Q Z naught Q. So this is the CFG construction from the given PDA. Thank you.